Carla Robledo is a Senior Policy Advisor at the Ministry of Economic Affairs and Climate Policy of the Netherlands. And she holds a PhD in the chemistry, where she researched lithium-ion batteries and hydrogen storage. And since 2019, she's working at the hydrogen team at the Ministry, where she contributed to the development of the hydrogen strategy published in 2020, and since then working on its implementation. Her focus with the team is on underground hydrogen storage, imports and international cooperation. She is representative on behalf of the Netherlands for the Clean Energy Ministerial Hydrogen Initiative and the IEA Hydrogen Technology Collaboration Platform. Carla, the floor is yours.
Thank you, Serge, for the introduction. And I'm very glad to be here, Hadi. Thanks for the invitation. I will be telling a bit in general what is our hydrogen policy, what we're doing at the ministry, and then as well zoom into also the hydrogen storage policy. So what are the main drivers that we have, especially I think it's interesting for also the international people present here. What are the main drivers in the Netherlands? Why are we setting in on hydrogen? Mainly we have a large existing use of grey hydrogen coming from natural gas in the industry at the moment in the Netherlands, around 175 petajoules. And we also foresee, so we need to make this more sustainable. And we also foresee for new applications like in mobility, also in dispatchable power, that we will need large amounts of renewable and low carbon hydrogen. As well, we do have a large potential for offshore wind at the North Sea. The targets are at this moment around 20 gigawatts by 2030 and 70 gigawatts by 2050. So we have very large ambitions. And we are constructing a lot of offshore wind parks, but at some point this energy is very difficult to bring to the mainland, especially with the wind offshore parks being constructed deeper and deeper in the sea. And so we also are looking at offshore hydrogen production and using also the existing infrastructure that we have for gas at the North Sea, how we can transport this energy in the form of hydrogen to the Netherlands. And of course, we have a very a very extended infrastructure for gas with low calorific pipelines, also for high calorific natural gas transport. And because of shutting down the production in the northern Netherlands in the Groningen field, then a lot of this infrastructure will become shortly available and which we can reutilize. So we have made studies together with Hasuni, the Dutch national gas grid operator, also with TenneT, the electricity gas operator, and we have evaluated that the potential of establishing a national hydrogen transport grid, and by reutilizing around 80% of existing infrastructure, and not only the infrastructure, but also the knowledge around the whole gas system is also applicable for hydrogen. So it is good for also the economy, the job generations in our country. So this is very important that we also make use of this. And of course, the large potential that we have for underground hydrogen storage, this is really, in comparison to other countries that don't have this potential, it's an advantage that we also allows us to construct this system in the Netherlands. So our main the main strategy that we have developed, it already started appearing hydrogen as a topic, as a thing, the political agenda in 2019 with the climate agreement. That was the first time that hydrogen appeared there. And we said, okay, the ambition will be to have around 3 to 4 gigawatts. But what does that entail and how we will reach those targets? We established in 2020 the government hydrogen strategy. And there the main focus, and we are now implementing it, but we can summarize in these 4 main topics. So innovation is key. We're setting a lot of resources in developing new technologies and supporting pilot demonstrations, also developing skills, human capital agenda is very important to have the people that will be doing these these projects. So innovation and research and development has been keen the last years. Also focusing on the market development, how we'll ramp up the production of renewable and low carbon hydrogen in the Netherlands, and what type of offtake we will have, how we can match the production with the demand side. That's also one of the core elements on the hydrogen strategy. And the infrastructure has been keen, and maybe this is what really differentiates us from other countries. The Netherlands has a very particular position with a relative constrained geography. A lot of infrastructure that is already in place that can be reutilized for hydrogen. So we are taking advantage of these aspects. And even though we say we want to produce here in the Netherlands around in 2033 to 4 gigawatts of electrolysis in place, we know that this will not be enough to suffice our hydrogen demands. So we also need imports. And therefore, the international cooperation, establishing these international supply chains is very important. That's a very strong pillar of our strategy. This we're not doing alone. I will tell a little bit more about the National Hydrogen Program. We are working together with all the stakeholders on achieving this. And this is one of the points that I would like to stress. This collaboration is fundamental. This summer school is a very good example where all these different stakeholders come together, and we need more of this. Also summarize here the main key targets, and maybe a takeaway key targets to remember where do we want to be in 2030 with hydrogen to support the climate goals. So we have from the European Union, we have obligations. These are almost finalized. So around 42% of the industry's fuels will have to be renewable fuels of non-biological origin. That means a lot of hydrogen. Basically, with hydrogen, we can fulfill these targets. So we have a large existing industry. That means for the Netherlands, a large ambition to replace these volumes, and at least 1% of renewable fuels of non-biological origin as a sub-target in the transport sector. So that is also a large amount. We're talking around 60 to 80 petajoules in total, depending on which sectors will be accounted for in the industry. The production in the Netherlands, then we have set the targets around 500 megawatts in 2025. And 4 gigawatts in 2030. And very recently we have sent a letter to the parliament where we say, okay, we will try as well to have an aspirational goal in 2032 around 6 to 8 gigawatts. So you see the ramp up, how fast it is going, and faster than that is also not possible because we need the offshore wind parks to provide this electricity to produce the green hydrogen. And that's why also that target for 2032. Before that, it's just not possible. And then the imports, we don't have any hard targets on the imports. That is very, at the moment, developing. We are seeing a lot of projects focusing on green ammonia as main carrier, but we're also trying to stimulate other routes because we will also have a constraint on the infrastructure to import that's ammonia, but also to transport it within the country, also towards Germany. So we also want to focus on liquid hydrogen, also on liquid organic hydrogen carriers, trying to diversify the type of carriers, but also diversify the origin where these imports are coming. So we have a lot of MOUs. We're talking with a lot of different countries, regions, to try to get the imports and really place the Netherlands as the energy hub, the hydrogen hub within Northwest Europe, where it can come in here and it can also be transported to our neighboring countries. With the infrastructure I mentioned, this is it's not very good quality, the image, but you see the same ring structure basically of the gas transport infrastructure. That's because we will reutilize part of it, and then Some blue spots here are new constructed pipelines that are needed to connect the main industrial sites, the 5 industrial sites in the Netherlands, and at the northern Netherlands to have also the storage of hydrogen in salt caverns. As I mentioned, this we're all doing together in a public-private program. It's called the National Hydrogen Program, where we have per sector of the supply chain for production, for transport, for end uses, for several parts of the chain. We have different subgroups with public and private parties involved, and we have come to a roadmap, or where do we want to be in 2030 with all these goals, and we're working together to implement it. So besides the policy, besides the support that is needed, we are now in this phase where we need to start implementing. There are a lot of plans, a lot of projects, but we need to keep pushing forward to make these projects a reality, and for this we need the collaboration among all the stakeholders. Now, zooming in a little bit more in what we're doing on, regarding underground hydrogen storage. So we started a couple years ago with some technical studies commissioned by the ministry on more technical assessments. First, on understanding what the storage, the general storage potential is in the subsurface of the Netherlands, so not only for hydrogen, but also looking at CO2, also looking at other techniques, and then we zoomed in into also the energy storage needs. So if we have all these goals, if we have all these ambitions, what are the storage energy needs towards 2050? From there we got a really large how do you call this? Really large bandwidth within how much hydrogen storage we need, because we really don't know how this hydrogen market after 2030 will develop. There's certain uncertainties where we hope that in the coming years it will be more and more clear what the role of hydrogen will be in the energy system. We have also initiated from the ministry the IEA Underground Hydrogen Storage Technology Collaboration Program to gather and share the knowledge. We saw a lot of stakeholders were looking into the topic, and we wanted to have more connection, also to learn from what is going on in other parts of the world, and we're very happy with this, with also the technology monitoring report. Hadi, Serge, the work that you're doing is fantastic to really have one place all this information that we also from policy we can use it to take the decisions that are needed for the implementation. As well, Uni Energy Stal have started with tests in salt caverns. They have also received subsidy from innovation programs to perform this. And then last year we declared the project of the development of the salt caverns in the northern Netherlands as of national interest. Therefore, this coordination schemes applies to coordinate all the permits that are needed. There are a large amount of permits that are needed, and it's a very complex process. So from the national government, we are coordinating this. The last 6 months, approximately, we have been working on a roadmap for energy storage. And here, this is wider than hydrogen. It's also looking into electricity needs for storage, also in the heat storage. But for hydrogen, we also said in this roadmap all the actions that are needed until 2030 to speed up the developments and what kind of support is needed. So actions like also coming into more determining the locations will be storing hydrogen, the funding gap that is needed. All these actions have been put in this roadmap and is also available since short online. And also this week, we also published the program on the energy main infrastructure. And here we look at more the implementation, the spatial implementation of the energy infrastructure that is of national interest, how we want to organize this on a national level. And underground hydrogen storage is very important, so this is also taking in this more national program. Where we say, okay, we know where the potential is for hydrogen storage, but now together with the local communities, with the regions, with the people living in these areas, we need to come to the next locations where we'll be upscaling hydrogen storage, because we know that in the future, in 2050, even 60 salt caverns won't be enough. Where we'll be developing them, and eventually will we also be using gas fields for hydrogen storage. So all these location aspects, choosing where, this will have to go on now forward with also regional consultations. As I mentioned, there are a lot of permits. Maybe our colleagues from SODM in the afternoon will also be tell a bit more about this. But I want to mention from these coordination scheme, which are the permits that are being coordinated. As you see, a lot of competent authorities are being involved. So ministries, different ministries, regional governments, also the supervision, the state supervision of mines. And it's basically divided in 4 activities. So first, determining the hydrogen storage location, then the development of the salt caverns, also the surface installations, and of course, looking at the operational phase and what the impact of those activities would be. And this, all these permits are coordinated in this scheme with 9 steps. This takes around, if it all goes well, no problems in the local region, then you would have around 2 to 3 years needed. We also see some now a shift of the planning because this is a very complicated process. It's also the first time we're doing this in the Netherlands. Also for this type of storage, the first time in the world for these more cyclic storage. So now we are in the phase of establishing the research that is needed for the environmental impact assessment, the scope, the details, the place where the inside vending in the northern Netherlands where this will happen. There are also other storage activities in place with the natural gas. There's also other initiatives looking into compressed air storage. How will these interactions have an impact there? Well, now we are just hearing, we really don't know all the risks and possible microseismicity. We don't want to repeat problems that we have generated in the past with gas production, so we need to look very carefully and address these problems correctly if we want to succeed in having these projects. And in all these steps of the process, there are several points for consultation, where also the local region, but anybody can react on the plans and have a say in it. So this is also how we try to have involvement of the whole social society. I will summarize a bit then this is what we have been doing, but where do we want to go and how do we see the further policy development? So as I mentioned, in this first phase where we are until around 2025, we have been already analyzing the storage needs. We have that, we know how much we will need. And also the European regulation is being put in place with a decarbonization package that will look more into regulating the type of third-party access for storage operations. We need to start, once this is published, we need to implement it also in national policy and regulation. And we need to start preparing for also, this is the permit procedure for the first storage in salt caverns, and having financial aid and support that is needed to establish this. Then more between 2025 and 2030, we foresee a more development phase of this first project, but also we need to take decision on whether we will start also a pilot or a first-of-a-kind project of underground hydrogen storage in gas fields. And we also need to start preparing the conditions for additional capacity of storage if we see that the market uptake goes fast, and also possibly decide on strategic reserves. Will we have strategic reserves? That's a very open question. At the moment, we cannot even think about if we still cannot have the storage location we need to have a balance of supply and demand, of even think about making these large parts of a strategic reserves, but we need to think in the future if we will be so dependent on hydrogen, what if the import flows stop? What if we have a bad year of wind, of solar? How would that impact in the hydrogen storage needs? So all these decisions are key in the next phase we are coming into. And after 2030, well, we see a scaling up of the storage capacity. We hope to have sufficient storage facilities built in time, and also possibly looking into offshore. Offshore, we will have all the wind parks, we will have hydrogen production, and we're also looking with the countries around the North Sea to collaboratively have this infrastructure. It will be logical to also look at offshore storage locations if we have production. So a lot of things that have to be thought well ahead in time, because all these projects have large development lead times. So we need to already, what's very, maybe going next to the challenges, what's very challenging is how to take all these decisions, knowing that it takes a lot of time to develop projects, but also with the uncertainties that we don't really know if we will need it. Then will they be stranded assets, all these investment made, and in the end it won't be needed. Those are things where we, from policy, really struggle with how to determine the exact storage needs and that it will be in time. Also, the technical issues, well, hydro storage in gas fields, there are a lot of research, a lot of first piloting tests, but also in the Netherlands, the conditions are different than in other countries. So how, we haven't proven that yet. We need to prove that first in the Netherlands to understand if we can implement it or if we will only rely on hydrogen storage in salt caverns. Regarding the spatial impact, well, the Netherlands is very highly populated. We don't have much space for new activities, and especially in the northern Netherlands where the potential for storage in salt caverns is, there's not a lot of acceptance for these type of activities in the subsurface. So if this really, we cannot scale, we will try to do it on land, but if we really struggle with these projects, then we will look to have it offshore, of also alternatives, looking to work together with Germany for collaborative storage. But this will also mean that if we do offshore, it will be more expensive. So you have to put in balance the economical feasibility, but also the social feasibility of these projects. And especially also not known much the interaction with other types of storage in the subsurface. And last but not least, the social acceptance. So I mentioned it indirectly, and in general, the public perception of hydrogen. Well, we hear a lot, but is hydrogen not dangerous? And people want it, but as far as it's far away from where they are living, that the storage is being done, or the production, or it's more seen like an industrial thing and not something that is done near the residential areas. And also how to assure the safety on the long term. So we know that also with salt caverns we will have subsidence. How can we also address these problems for over 50, 100 years, and that we don't know, we already think about the solutions and not only create problems. So with these challenges, I hope I give you a bit of impression where we are concerned from the ministry, and I'm happy that you're also here to think along with us and also to provide solutions for these challenges. Thank you.
Thank you very much, Carla. A lot of challenges and a lot of hands already. So I'm going up. Some questions for you.
Ah, okay. I thought the discussion was after.
Hi, yeah, thank you for the presentation. My name is Ella van der Veer, work for Shell, and indeed you've already touched upon the fact that social acceptance on shore especially is probably going to be an issue. I think we've also seen that with Barendrecht CCS, for example. In conventional oil and gas permitting, we are looking at benefit sharing more and more as a mean to mitigate this in a sense. How do you see the role in that for hydrogen storage?
Yes, definitely. We need to look at these types of constructions, benefit share, but also making people also co-owner of these facilities. That was one of the main advices from the parlementaire enquête from Groningen. Make people also owner of these things and of these activities that we are endeavoring, and that would be one way to increase the social acceptance of these projects.
Would that mean that communities could be a kind of a joint venture party in such developments, the local communities?
Yes, like also wind parks, and then there are corporations, and then people are owner of one of the windmills. I know Gasjini is looking at these possibilities, so this has to be in consultation with the region. It's not like, okay, let's just throw money at them and it's done. It's just listening to what are the needs, also stressing the importance of this. This will be the heart of the energy transition here in Groningen. We need this for everybody, for also the people there in Groningen, but how can they profit from it?
Hi, Carla. Great presentation. I think it was one of my favorites of the whole summer school. This is Augusto Correnti from Shell. The first question that I have for you, I have two, is you mentioned, I think you put a lot of emphasis in green hydrogen on your whole presentation, but you also mentioned gray hydrogen, and you also mentioned interest in CO2 storage. So I guess the question is, why is there not more emphasis on blue hydrogen as well, from your perspective as a regulatory agent, let's say? And then the second question is, you mentioned international cooperation. You said something about the North Sea countries, and also you mentioned something about Germany, but then you also said something about imports. I'm curious if there are already ongoing some strategic partnerships with some other countries. So thank you.
Yeah, thank you, and great questions. So regarding blue hydrogen, or we call it low carbon hydrogen, yes, it is. It's not part of our strategy in the sense that we put a lot of money and support on it. We see that the new technologies with green hydrogen electrolysis really need a lot of support to get from the ground. The largest one in Europe is only 20 megawatts. If we want to go to gigawatt scales, and we're not the only ones, Germany wants 10 gigawatts, and then Spain also 4 gigawatts, and if we want to achieve this upscale, we need to support these technologies that are now on a low TRL level in terms of implementation. And for CO2, we do support CO2 storage, and some of these projects that are looking into blue hydrogen are getting indirectly a subsidy for the CO2 storage part. But we want to also not create on the long-term lock-ins with these. Okay, let's have new blue hydrogen projects. Over 20, 30 years, they will still be here. We want to reutilize what is being done now with gray hydrogen. That gray hydrogen, you can already make it blue by capturing the CO2, but not have new projects on blue hydrogen. We want to stimulate the green hydrogen production part. And then regarding imports, yes, we have a lot of strategic collaborations. We have also recently sent a letter to the parliament about our hydrogen diplomacy strategy, and we are mainly prioritizing the hydrogen corridors, we name it, with Canada, with America, or firstly with Europe. It's very important to develop things as close by the Netherlands as possible. Also the security of supply, being independent from other countries outside of Europe. So with Spain and Portugal, the southern part of Europe, we're doing a lot. We actually were recently with the King of the Netherlands in Spain for a hydrogen visit. It's the first time that this happens. The King is especially interested in hydrogen. He wants to promote this, and this is the highest you can inset from a government on energy diplomacy level. So this gives the indication how important the Netherlands is finding this. And then also with the northern part of Europe and Norway, this will be very important. And outside of Europe, America, Canada, we're also looking with Latin America. We have with Chile also a strategic agenda of cooperation, with Uruguay, with the also with Australia, with African countries. We have with a lot of them, we are having a lot of conversations and really also sharing a lot of knowledge. You see, at the beginning, we were very front runners. So a lot of countries were coming for us for knowledge sharing. And now we are basically all in a level playing field. And we also need to learn from other parts, share this knowledge, but also try to go more towards the implementation of these supply chains.
Yeah, so quick question. Hi, Carla. So with this emerging market for hydrogen storage, there's multiple countries that have excellent geology for development of storage. How is the Dutch government incentivizing all these investments in these companies to come to the Netherlands, but not to Germany or Poland or some other, or Denmark for that matter? How are you removing the barriers in the regulatory space to attract the business here?
Yeah, thank you for the question. Well, we are now very much focused on having this first project getting realized. Is very important also for the operation of the national grid. We do have now reserved from the climate fund 250 million euros for hydrogen storage. And now we're making an instrument to this. We think about a tender or a subsidy scheme, and then that would be open for other market parties to also apply for. But that would be then for the further scaling up of hydrogen storage. And of course, this is not enough. A lot more is needed. But it's also needed for other things outside of hydrogen. Hydrogen is only a small part of the whole energy transition. Yeah, we will also look forward what kind of support additionally is needed. But all this is also done with our RVO, our implementing agency, to open these tenders open and public to other market parties.
Okay, thank you. Again, applause for
Thank
Carla.
you.
Thanks a lot.